Hello, ladies and gentlemen, and a warm welcome to this virtual conference. Thank you very much, AIP, for organizing it and having us here. It's a great pleasure for me to talk here to you today. Now, although this is a recording, please, if you have any questions, put them into the chat. Our local sales representative, Gary Brown, is happy to take your questions. For all of those who are watching this as a recording, my contact details are at the end of the presentation, and if you have any questions, please feel free to contact me anytime. I'm Andreas Stoiber, and I would like to talk to you today about closing the loop in rPET packaging, and particularly looking into tray-to-tray recycling. I am working for a company called Starlinger Viscotec, based in Austria. We are specialists in rPET recycling. We have 250 plants installed worldwide, on which a week 2 million tons per annum are converted from post-consumer recycled PET into food-grade PET. Starlinger is a company which is family-owned. We have 250 million annual turnover and about 700 employees. And with that, I would like to talk about the Viscotec division a little bit. The Viscotec division has two main products. One range is for PET decontamination and improvement of mechanical properties. And the second product range is producing sheet out of these decontaminated IV increased PET input materials. Right, and before we are looking into the challenges and opportunities of PET tray-to-tray recycling, I would actually talk a little bit about the situation we have at the moment. Now, one of these facts that define the situation is a growing demand in packaging. A couple of trends which are supporting that: growing population, more single households, more food on the go, which asks for functional packaging, and most recently also Corona plays a little bit of a role in that. Another fact is that the market is asking for more recycled content in the packaging. And this is not only because of brands and consumers, but most recently, especially in Europe, also the 2025 defined recycling goals. Other countries like the UK, for example, also have such goals even earlier, 2022. And what is also on the table about these legislative recycling goals, which is asking for PCR content in packaging, is a penalty system, which is not yet defined, but it is definitely on the table. Another fact is that we're still having rPET downcycling, as in input materials are used not for recycling from food packaging to food packaging, but for example, from food packaging into fiber, strapping, other applications. And in our view, this is material that is lost for true recycling back into food packaging again. So this is also a fact that we need to consider. And there is already a high demand in bottle flakes. We know this for certain because we sold a very big amount of capacity, which is going online the next 12-18 months. And through this capacity, there will be an even increased shortage of bottle flakes. So the industry really should or have to look for other sources for input material to make food packaging out of recycled materials. Well, the good news is that PET is still best suited for recycling in the food packaging industry. The reasons are it is relatively easy to decontaminate, and another big advantage is that mechanical properties can also be reinstated and increased from the recycled material, which is not possible with any other materials in the plastics world. Another thing to consider is that the PET tray flake is considerably lower priced than bottle flake at the moment. Now, how this is of course going to develop in the future needs to be seen, but right now the PET tray flakes are definitely on a lower level price-wise than the bottle flakes. Right, and with this I already want to present to you our vision or our idea. How can we close the loop with rPET? So here you can see on the left side the loop of the bottle recycling, which is already implemented, very well established since decades. And on the right hand side you see the tray to tray loop, which also the goal is to actually implement it the same level as the bottle to bottle. And you can also see that these are flowing into each other. This is technically absolutely possible and in our view also necessary in order to talk about a real circular economy. Now let's have a look at these loops in particular. First, the bottle to bottle loop. Here you can see a tick list of what has already been achieved by the industries, the food packaging industries, as well as the plastics industries coming together and implementing or making this recycling possible. So no contaminants with additives, they've been eradicated. All the labels or complicated to separate labels have been as well taken out. Labeling in colors has been designed in a way that recycling is possible, and collection systems are established pretty much all over the world, as well as, and this is a very important point, the legislations and rules. Because obviously, if you're especially working in the food industry, you have to work to a very high set of standards with a legal framework behind it. Now, this tick list is turning, to be honest, into a little bit of a to-do list for tray-to-tray recycling. But one tick's already there, as you can see, and this is, as I mentioned, a very, very important tick, the clear legislation and rules which create the framework to make it legally possible and safe for everybody, the consumer and the producer, in order to use recycled materials. The other things need a little bit more attention and a little bit improvement. So there is still contamination with additives in trays. There is still multi-material trays like PET, PE laminated trays. We still have to look at labeling in colors in order to make recycling as simple as possible, and collection systems. Collection systems, of course, we can use whatever is already in place from bottle to bottle, but they need to be extended or modified. So as well here, a little bit more attention is required. That brings me already to the challenges of tray-to-tray recycling. We defined 4 crucial ones, which I want to talk in detail about. One would be intrinsic viscosity, or IV, which is basically a measurement of how mechanically strong the material is. I mentioned it before, in PET it can be reinstated, so that's a pretty good thing for PET. The second one is recycled content. How much percentage of recycled material can we actually technically use? And the other two, monomaterial as well as defined streams, are another prerequisite and a little bit of a challenge which need to be tackled and looked at. Now let's have a look at the intrinsic viscosity in detail. It's getting a little bit technical for people who are not so familiar with it, but bear with me, I try to explain it. Usually a bottle flake, so a recycled bottle, has an IV of 0.72. With these flakes, very often the trays are made, and through every conversion process from flake into sheet, for example, you lose a little bit of IV. This is in the nature of the process. So depending how well this process is working, you lose a certain amount, and the average IV in collected trays is resulting in 0.6. So this is a little bit on the low side. So what we need to do in order to actually enable the packaging to do what it's supposed to do, namely protect the food, we need to lift this back up about 0.1 to 0.12 in order to be able to make a functional packaging again. This is the first challenge. The second challenge, as I mentioned, what is the maximum recycled content we can use in a food packaging? And you can see it here on this diagram already very well. There is only two types of input material required. One type of input material would be the post-industrial regrind, which is a waste or a regrind that falls off the thermoforming process. Again, this is in the nature of the process, especially if you're making cups. This can be used up to a third, and the rest of the packaging, 2/3, can be made out of post-consumer bottle flake or tray flake. I should say and or, because of course you can also mix them too. So technically it's absolutely possible to make food packaging out of, so to say, 100% recycled input material. The next challenge is, we call it monomaterial. What do we mean by that is a packaging needs to be designed for recycling. Like a bottle is made of 100% PET. Also the tray needs to be made out of 100% PET, because materials like PE, as I mentioned before, are a bit of a disturbance in this recycling process and really have in our view, no technical reason to be there, because there is already very well working alternatives on the market. The market, just under brackets, needs to be taking them on and implementing them. And another thing to consider is the lidding film. So if you have a form-fill seal or a fill-seal process, you need certain lidding films which are welded on top of these trays, and also these we need to consider a little bit in more detail. And another challenge is we need to have defined streams for collection and subsequent recycling. Pure streams are absolute key to circularity, just like it works in the bottle industry. So how do they look? Really, first and uppermost, we need a separate recycling stream for clear, transparent PET packaging. Why? Because it is the most simple and biggest amount of packaging is clear. And as a further step, we would think it would make sense to have another stream for white, and maybe as a third step another stream for CPET. Why white? Because a lot of tubs, cups and trays are made in white for the dairy industry. And we believe that the dairy industry, probably more like in the midterm, is going to look at PET as a packaging material. And as well as with bottles, it is the same with the trays. Colored trays should really be avoided because the recyclability is actually quite a bit lower. Right. Now, with these challenges, how would a recyclable tray, or what we call an eco tray, look like so that we can implement true recycling? Well, first of all, it should only be transparent or white or CPET. So with these, and this is of course depending on the streams that are implemented. The best and easiest would be transparent. It has to be, and this is extremely important, a monomaterial, so there should be no PET/PE, and labeling and colors should be considered a little bit on the lids, and I would really like to talk about this in a little bit more detail on my next slide. So I mentioned it already, the tray should be 100% monomaterial, not printed and no label on it. Why not printed? Because printer inks just will never enable you to make food grade packaging out of this packaging again, because they're very difficult to be washed off. If they are washable, then they would also be vanishing in the supply chain, so it really isn't working out very well, to be honest. And labels are also a bit of a disturbance since they're very difficult to remove. Now let's have a look at the lid. Now our view is that the lid should be, or can be even, or should be a different material to PET. The reason is PET has a density of above 1, and the lid could have a density of below 1. The advantage of that is PET would sink in water and the lid would then float in water. So it is very, very easy to separate those two in what we call a sink float tank. And this system is already in place all over the world since decades in the bottle-to-bottle industry. So we can use existing technology in separating those two streams very easily. Now, what would be the advantage of that is you could print the tray lid, because we have to print or put some information on the packaging somewhere. For example, nutritional facts. In many countries it is mandatory to put these on, so we have to have some opportunity to put them somewhere. And the lid would be an ideal place because it's very visible, the consumer sees it right away, which also leaves a little bit of place for branding or other information. And since these lidding films are always much, much thinner than the actual tray, we also have the opportunity to put barrier materials inside. Please remember, that the tray should be only monomaterial, but the lid then could be also having a multi-material structure, which is then separated. So what would that result in? We would have a real recyclable PET tray, which is probably 95–98% of this packaging in weight, plus a lid or closure, which is still recyclable, but downcycling as we define it, because it could be not going into, if it's printed, for example, not going into food packaging again. But we could make something else out of it, like a flower pot, for example. And then in total, we would have a real recyclable food packaging. So if we are looking at the conclusion of this philosophy, we have two big areas we should be taking care of. One is upcycle the PET in mechanical properties, so lift the IV, and the other big area is super clean the PET so that it is actually fit for direct food contact. So, upcycling PET, that sounds very technical, and it is. If you look at this graph, I try to explain what we mean and why this is so important. On this graph, you see this intrinsic viscosity. Remember, this is responsible for the mechanical strength of the packaging over the life cycles. And the green dashed line gives you an optimum level of this IV, and the red line gives you a critical limit where you should not be below out of process reasons. Below this line, the PET becomes quite brittle and it would be causing issues already in the sheet process, in the thermoforming process, and in the end also in the packaging, because if it is too brittle, then it would not protect the food in a way that is supposed to be. So if we're now taking, for example, a high IV input material like virgin and we're extruding the first time, we're going down with the IV a little bit, again out of the nature of the process. Then the packaging is produced, used, collected, crushed, washed, put back to the sheet producer, who is lifting the IV again in order to have this optimum level. Then we're extruding it again. And then again, usage, recycling, lifting IV again, and so on and so on. And you can see the different life cycles here. Important is, okay, we might not be always in the optimal level of IV, but absolutely crucial is to stay well clear of the critical level. And this is how we can go on with quite a couple of life cycles, I would almost say endlessly, in PET packaging. Units which would be able to do so, you can see here the Decon IV Plus on the left hand side, which is doing exactly what I explained before, increasing IV, making the material food grade from post-consumer, recycled, dedusting it, drying it, so the material is totally optimal, prepared to go into a sheet line, a visco sheet line as we call it. This line is purpose built for rPET input materials, tray waste, bottle flakes, preform scrap, whatever you can imagine, would be possible to implement or introduce into the sheet line in order to make 100% rPET sheet for tray production. Yeah, and with this setup, you would be achieving exactly what you need, food grade rPET without compromise. We stand for that with our name. We have 100% rPET approvals all over the world, your FDAs, your EFSA, your Mercosur, whatever you can imagine, we will fulfill it. And with this, tray-to-tray recycling would be possible and absolutely achievable and would be supporting the circular economy. And with that, I would like to thank you very much for your attention and wishing you a very good virtual conference further on in the day. Thank you very much.